Hello, everyone, and thank you for joining today's session about Amazon DocumentDB performance optimization. My name is Douglas Bonser. I am a senior DocumentDB specialist solution architect based out of the Dallas, Texas area. Been in IT for about 30 years now, working with document databases for the past 6 or 7 years now, so very familiar with technology and the use cases, and looking forward to really digging into monitoring and visibility best practices on DocumentDB. So brief overview of the agenda. I'm first going to level set with a discussion of benefits of document databases and an overview of Amazon DocumentDB. Then going to dive deep into the bulk of the session on monitoring and visibility, starting with how to view available DocumentDB metrics in the Amazon CloudWatch. Next, move into using the profiler to find slow running queries in your cluster. And then using performance insights to visualize load on a DocumentDB cluster. Moving on to auditing operations performed on a DocumentDB cluster. And finally, how to subscribe to events that occur on resources in a DocumentDB cluster. And then I'll be doing multiple demos of these capabilities throughout the session. But to start, I want to briefly consider some benefits of document databases and an overview of DocumentDB. So a little history, if you will, right? So for decades, really, three-tier architectures have been common in enterprise applications. And in this type of architecture, applications are organized into 3 tiers or layers. The presentation layer, which is the user interface, the application layer, where the business logic resides, and the data layer, where the data associated with the application is stored and managed. And in these types of architectures, many times we see that data layer relies on relational databases and in the rigid schemas. Now, while the application is split out into these separate tiers, it is still monolithic to an extent because each application has its own layers, its own presentation layer, application layer, data layers that are deployed together. And these applications can frequently become very large, complex to scale and maintain. Because of this, we see many 3-tier applications being targeted for modernization, where they're broken apart into smaller pieces and moving towards a microservices-based architecture, like you see here. So in this microservices-based architecture, applications are designed as a collection of services. So here we've broken apart the monolith that we saw on the previous slide by decoupling the various pieces. And each piece or service is now talking to one or more other services. So you see there's a lot of communication between them, and JSON is the predominant format of the data in the communication amongst microservices. And in this architecture, document databases are frequently used to store those JSON documents. Some of the reasons are JSON's simple markup, easy to read format, and lightweight composition make it easily transferable from system to system. And it's also used not only between these services, but within each of them. So it's in this kind of architecture, it's really JSON all the way. But I want to now look at Amazon DocumentDB, which is a fully managed document database service that, as you see here, is highly scalable. The architecture of the service, which separates storage from compute, allows you to easily scale each of those independently. You can scale compute horizontally or vertically in minutes, regardless of the amount of data in the cluster. And that cluster can be scaled out to a maximum of 15 read replicas to support millions of reads. And storage in DocumentDB automatically scales from a minimum of 10 gigabytes up to a maximum of 64 terabytes. DocumentDB is a fully managed service, so there is no hardware to provision. There's easy setup via the AWS console, which allows you to spin up a cluster in minutes. And the service provides built-in high availability with clusters automatically provisioned across multiple availability zones. Now, in terms of best practices, in DocumentDB, backups are enabled by default and can't be turned off. Data is highly durable with 6 copies of it across 3 availability zones. And secure settings are the default. Things like data encrypted at rest and in transit by default. And then as a managed service, patching and maintenance are handled by the service, removing that heavy lift, taking care of the heavy lifting for you. And then finally, to simplify technology stacks, there's native integration with multiple AWS services such as CloudWatch, which we'll be talking a lot about today, for monitoring and alarms. And finally, DocumentDB is compatible with MongoDB 3.6 and 4.0. It implements the Apache 2.0 open source MongoDB 3.6 and 4.0 APIs by emulating the responses that a MongoDB client expects to get back from a MongoDB server. So this allows you to use existing MongoDB drivers and tools with DocumentDB. So DocumentDB does support hundreds of APIs, operators, aggregation stages, and data types. We don't support 100% of all of those that Mongo supports. So we are continually working backwards from our customer requirements to implement more APIs, operators, aggregation stages, and data types. And just to round out the introduction to the session here today, in terms of monitoring, which is really the focus, it's split. There's two areas of responsibility, right? AWS responsibility and your responsibility. So in terms of monitoring, AWS provides over 50 metrics published by DocumentDB and available to view and monitor within CloudWatch. Native monitoring tools, like I mentioned, just CloudWatch, Performance Insights, profilers, built-in log collection, publishing, and alarm capabilities. So that's what AWS provides. Now, you're responsible for enabling and configuring these tools to meet your needs, monitoring metrics and alarming on them as needed, defining any custom metrics that you may need, and of course, analyzing CloudWatch logs generated by DocumentDB. So I want to start with some of the DocumentDB operational metrics and using CloudWatch to view them and how to set alarms on them. Now, these metrics fall into 3 main areas as it relates to the conversation here today. And those are metrics around instances, things like database connections and CPU utilization, storage and backup, how much storage is being used or consumed by the data and the backups, and then cluster metrics. For example, how many read and write operations are occurring in the cluster. So I do want to talk a little bit about this architecture because it is important to understand. So you see this separation of storage and compute here with the compute layer at the top. DocumentDB clusters will always have a single primary instance to handle reads and writes, but multiple replica instances that handle reads. You can have from 0 to 15 replica instances. That distributed storage volume that you see there, the storage layer, that is what handles the replicating or the replication of the data 6 ways across the 3 availability zones. And then the backup, there you see the arrows pointing to Amazon Simple Storage Service, or S3. All right, backup is offloaded to the storage layer, so there is 0 impact to the compute layer. So let's just dive right into instance level monitoring. All right, so this is the compute layer. So at the instance level, what you see here, these six metrics are metrics we recommend monitoring. And I'm going to dive deeper into each of these in the following slides, so I'm not going to spend too much time on them here. So the first 2 are buffer cache hit ratio and index buffer cache hit ratio. So DocumentDB instances utilize approximately 2/3 of the RAM on the compute instance for the buffer cache. And what the buffer cache does is it caches data and index information. So the more that you can cache, the better the performance will be. So these 2 metrics, and what they are, buffer cache hit ratio. So this is the percentage of requests served by the buffer cache. index buffer cache hit ratio is the percentage of index requests that are served by the buffer cache. So there's an important distinction here. Is index buffer cache hit ratio is dealing only with indexes that you have defined on the data. Buffer cache hit ratio, think of that as a superset because it has cache hit ratios for both index information and the data stored in your cluster. Now again, because you want to try to serve reads from that buffer cache, the value of these should be as high as possible, right? Ideally, you'd want to see 100% on these because reading from memory is going to be more faster and more cost effective than reading from that distributed storage volume. So that's cache hit ratios. Next is around connections and cursors. So DocumentDB supports multiple instance types as seen in this chart here. So the instances range from the smallest, which is a T4G medium, has 2 vCPUs and 4 gig of RAM, all the way up to the largest, which is an R524X large with 96 vCPUs and 768 gigabytes of RAM. Now, each instance type supports a finite number of database connections and cursors, as you see here. So for example, a 3-instance R6G large cluster can support 5,100 client connections, right? 1,700 times 3, because I've got 3 instances, and 1,350 cursors, which is 450 times 3. So these are hard limits. So we recommend monitoring these metrics, database connections and database cursors metrics. And if you see the number of connections or cursors approaching the limit for your instance type, that's an indicator that you want to check to make sure that your initial expectations of workload are still correct. Make sure that the number of clients and or the access patterns haven't changed. One area where we see this is clients who are customers who are deploying their applications in containers and auto-scaling those containers. So as those auto-scale and more containers are deployed, more clients are connecting, that can quickly consume available connections. And then also we see cursor limits being hit due to long-running queries, maybe that aren't using indexes, or code that doesn't close cursors after they're done working with the data. All right, so that's connections and cursors. And the last two I want to talk about here from instance monitoring are around memory and CPU. So in addition to the buffer cache that caches data and index information, about 1/3 of instance memory is used by the DocumentDB service itself. And the freeable memory metric is the amount of instance RAM currently available. So if you take out what's currently consumed by the buffer cache and the memory that's being used by the service for other things, that's what the freeable memory metric is. Right, and this should always be at least 10% of the RAM on the instance, right? We don't want that to get too low. Now, CPU utilization is simply the percentage of CPU being used by the instance. So we do recommend that sustained CPU utilization should be below 75%. All right, you don't want to see high CPU utilization for very long periods of time. All right, that is an indicator that instance may be undersized or you've got some inefficient queries going on. So to sum up the section here on the instance monitoring, a couple of best practices for monitoring and alarming on these metrics is you want your cache hit ratios as high as possible, right? Ideally 100%, but certainly over 95. And you may see occasional dips, especially during periods of heavy write operations. But again, we typically like to see these 95% or higher. Database connections and database cursors should be under 80% of your instance's limit. And then freeable memory and CPU utilization should be looked at just like you would look at these metrics on any kind of compute instance. Right? You don't want free memory to drop continuously. Occasionally is fine and to be expected. And you don't want sustained high CPU usage for very long periods of time. I want to talk a little bit now about some cluster level metrics that we recommend monitoring. So database cursors timed out, the second one on here, that metric indicates how many cursors have timed out after 10 minutes of activity, and this should be 0. All right, so if you remember, I was just talking about connection and cursor limits. All right, when the client connects to DocumentDB, performs some read operations, it's going to open a cursor. All right, and when the application is done with that data, it should close the cursor. So if you see database cursors timed out being anything more than 0, that's a good indicator that the clients aren't properly closing the cursors when they're done reading the data. Another one I want to talk about here right on the slide before I dig deeper into the others is this op counters. So there are multiple op counters metrics corresponding to the various CRUD operations that you can perform in a cluster on the data. And so they indicate how many of each kind of operation were issued. And you see here in this dashboard, the insert, update, delete, and query operation counts. So if you remember the architecture, there's always a single primary instance and 15 replica instances. So that primary instance handles writes and reads. Replica instances handle reads only. So that primary is handling all of the update requests, and changes that occur on that primary instance need to be replicated to the replica instances so that those replica instances can update their buffer cache with the updated information. Because of that whole process, replica instances are eventually consistent. Now the process and then the replication, it is fairly quick, but there is a metric that you can monitor, this DB cluster replica lag maximum, and that indicates the maximum amount of lag in milliseconds between the primary instance and each replica instance in the cluster. Now, some reasons that this might increase are very high write rates on that primary instance. Sometimes the replica instances may not be able to keep up with updating based on all of the updates that are occurring on the primary, especially if they're handling a lot of read traffic at the same time. Now, ideally, a replica lag should be within 10 to 100 milliseconds on the cluster. So this, going back to the separation of storage and compute, updates have to be written to that distributed storage volume, and data that's not cached has to be read from that distributed storage volume. The metrics that you see here deal with that, right? So write operations, or IOPS, we count those in 4K units, and DocumentDB does try to batch writes if possible. And then reads are counted in 8K units, just to give you a little bit more information about the difference between reads and writes. So another way to think of that is if you've got 8K worth of data, that's going to consume 2 write IOPS, but it's going to consume 1 read IOPS. Now the metrics that I'm talking about here on the slide, volume read IOPS, volume write IOPS, read IOPS, and write IOPS. They sound pretty similar, but the main difference is volume write IOPS and volume read IOPS represent the total count of billable IO operations for all instances in the cluster. All right, so this will give you a good idea of what you're being charged for IOPS in your cluster. Write IOPS and read IOPS, those are instance level metrics, and that shows the average instance operations per second rather than a total count. All right, and they don't account for the batching. Like I mentioned, we do try to batch writes and reads if possible into these 4K and 8K units. So write IOPS, read IOPS won't reflect that, but volume write IOPS, volume read IOPS will reflect that batching. So the way to use these metrics is not necessarily to alarm on them, but really just to validate based off of your benchmark testing. All right, are IOPS within the range that you expected, based on your testing prior to going live with your application. Now, some best practices for monitoring and alarming on cluster level metrics. This DB cluster replica lag maximum should ideally be between 10 and 100 milliseconds. Database cursors timed out should be 0. All right, if it's not 0, it means most likely that clients are not closing cursors properly. Volume write IOPS and volume read IOPS measure what you are billed for. Again, not necessarily something to alarm on, but good for investigating any potential issues. Op counters metrics can be used to validate expectations about the workload. Right? If you estimated you're going to have a certain number of read and write and delete operations, you can validate that with these op counters metrics. Okay, and then the third area of CloudWatch metrics are storage and backup monitoring. So the metrics that I'm going to dive into here in the following slides, you see on this here, volume bytes used, backup retention period storage used, snapshot storage used, and total backup storage built. So the first is volume bytes used. This is the amount of storage used by a DocumentDB cluster in bytes. And this is storage is a billable metric in DocumentDB. So this is a good way to give you an idea of how much storage you're consuming, have an idea of your storage charges for the cluster. Now, I did mention that DocumentDB maintains 6 copies of the data, but you're only charged for storage of 1 copy of that data. All right, and this metric reflects the storage of that 1 copy. There is a hard limit of the 64 terabytes per database, so you can monitor this metric just to make sure you're not getting close to that limit. Now, if you are using DocumentDB 3.6, I do want to point out that DocumentDB 3.6 uses a high watermark model for storage pricing. So if you purge or delete a large amount of data, you'll still be billed for storage at that high watermark. But what you see in the graph of the metric here on the screen is the behavior in DocumentDB 4.0, where if you do purge or delete large amounts of data, your volume is going to shrink. So I mentioned that backups are enabled by default and cannot be turned off. So DocumentDB continuously backs up your data to S3 for point-in-time recovery to any time within your defined backup retention period, which can be anywhere from 1 to 35 days. DocumentDB also takes automated incremental snapshots of your data as part of this continuous backup process. You can maintain and take your own manual snapshots if you need to retain snapshots past the cluster retention period. So again, cluster retention period from 1 to 35 days. 1 is the default, 35 is the maximum. If you need to store and maintain backups for anything past whatever your retention period is set at, whether that's 1 day or 35 days, you'll want to look at using manual snapshots to be able to store those for longer. But do be aware you are responsible for managing the life cycle of your manual snapshots. Right? You don't want to just be creating dozens or hundreds of manual snapshots and forgetting about them, because they will be consuming snapshot storage and you will be billed for those. Now, the metrics that you see here, backup retention period storage used. Another way to put that is the amount of backup storage used to support the point-in-time recovery based on your retention period. All right, so going back to, if I've got, say, 6-day retention period, all right, this is how much storage is consumed to support all of the incremental backups that are needed to support point-in-time recovery for that 6-day retention period. The snapshot storage used metric is the amount of storage used for storing manual snapshots beyond the backup retention period. All right, so using that 6-day retention period example, if I need to store snapshots maybe for 6 months, all right, so those are going to be anything past that 6 days. Those are going to be incurring charge based on this snapshot storage used metric. So manual snapshots are full snapshots. All right, with the automated backup that DocumentDB does. Those are incremental snapshots. Manual snapshots are full snapshots, and they do not point time recovery. So the way to use them is you do need to restore them to a new DocumentDB cluster. Then the last metric around backup and storage is total backup storage build. And this metric reflects the billable amount of backup storage. And it's the sum of the previous two metrics, right? The backup retention period storage used, snapshot storage used. But from that sum, we subtract an amount equal to the size of the cluster volume for that day. All right, because you can't turn backups off, and the default is 1 day retention period, we don't charge for that 1 day's worth of backups. So that's why you see the subtracting the volume bytes used to account for that free storage of the 1 days of backup. And then to wrap up the CloudWatch instance cluster backup and storage metrics, just a couple of best practices around backup and storage. All right, so while there are no recommended metric values to alarm on, it is important to understand these metrics, and so you can keep an eye on your storage usage and also help with cost optimization. All right, you want to understand your recovery point objective, which is going to drive your retention period. Right? Do you need to recover anytime to 1 day or 35 days or longer? Right? If you need more than 35 days, you're going to have to use manual snapshots. You need to understand your recovery time objective. Right? Do you have very low RTO? And if so, you probably need to use point-in-time recovery. So you might need to have a longer retention period. If you have higher recovery time objectives, maybe you can meet that with restoring manual snapshots, so you can have shorter retention periods. Two other things to keep in mind. If your data change rate is very high, all right, so you've got a set of data and it's changing a lot throughout the day, those incremental backups, there's going to be more data in those, right, because a lot of data is changing. So if in that case, if your change rate is very high, it might make sense to reduce the retention period and use manual snapshots instead. All right, it could work out that will actually consume less storage than a longer retention period. If your data change rate is low and you need to retain backups for a period of 35 days or less, all right, it actually may be better to extend the backup retention period because those incremental backups are smaller because less data is changing and you don't have to store those full snapshots. So again, something to keep in mind there based on your data set and workload patterns. And again, just to reiterate, don't forget about your manual snapshots. You are responsible for managing the life cycle. Okay, and a couple more slides here before I move into a demo on CloudWatch, talking about alarms, right? So now that I've talked about some of the common metrics to alarm on, just how do you create CloudWatch alarms, right? So CloudWatch alarms trigger based on individual metrics, right? We talked about a lot of these individual metrics up to this point, or combinations of metrics. For an individual metric, the alarm enters what's called an alarm state when it is outside a defined threshold. And like you can see here on this screenshot, the threshold defined on this alarm on CPU utilization is 14%. All right, so as soon as CPU utilization goes past 14%, the alarm is going to go into an alarm state. For a composite alarm, that will enter the alarm state when all rule conditions are met. So another way to think of that is you might want to set an alarm and send a notification when both CPU utilization is high and freeable memory is low, but not when only one of those conditions is met. So you'd use a composite alarm for that. The other thing you need to do is specify what action to take when the alarm goes into the alarm state. Most common type of action is to send a notification via Amazon Simple Notification Service, or SNS. And alarms can also be used to trigger scaling operations. For example, you could use alarms on CPU utilization to scale out read instances in a DocumentDB cluster. And just a screenshot here of an alarm that is in alarm state. You can see there on the top right, it says in alarm. So you see here that CloudWatch shows the current metric value in relation to the threshold. So that threshold was 14. You see the current metric value is somewhere around 15. All right, and you can see very clearly that it exceeded it and that it is triggered. So with that, I'll transition into a demo of CloudWatch metrics and alarms. So what I want to show first is the cluster information. So in the series of demos I'm going to be doing in this session here is all using this getting started with DocumentDB cluster. And when you go into the cluster, you notice a monitoring tab. Right, so just right within the DocumentDB console, you can view these metrics. You can't set any alarms on them or anything like that directly here in the DocumentDB console, right? But you can take a quick look at these directly here in DocumentDB console. So right now, though, I want to go to CloudWatch and look at a dashboard that I've pre-created with some of the metrics that that we've talked about here. Okay, sorry, clicked the wrong thing. Yeah, so you see a lot of the metrics I talked about, like buffer cache hit ratio, index buffer cache hit ratio, database connections, and cursors. Right, so you can see a lot of these metrics that are already here. Just wanted to walk through adding one or two metrics to this dashboard so you can kind of get a feel for what that looks like. So what I'm going to do is add a CPU utilization, add a widget for CPU utilization on my instances. So I'm going to use the line widget, metrics, and I am going to look in the DocDB namespace. And again, these are instance metrics, right? CPU utilization is an instance metric. So once I get into the instance metrics, I can then search for CPU utilization. And I can see my 3 instances. And by getting started with DocumentDB cluster, go ahead and create the widget. Right, and now I've got a widget in my dashboard for the CPU utilization instance level metric. Now for a cluster level metric, the process is pretty much the same. Or just be looking at a different, a different namespace. All right, in this case, I'm going to look under cluster metrics. All right, I want volume write IOPS. I want to see how many writes, how many of these 4K writes are being consumed, updating data in the distributed storage volume. So let me get volume write IOPS. And since it is at the cluster level, there is only going to be one entry for it because I only have one getting started with DocumentDB cluster, and I can go ahead and create the widget for that. So that's how to create instance level and cluster level create widgets for those metrics in an existing dashboard. So in terms of alarms, I want to go ahead and create an alarm, walk through how to do that. So we go to the alarms section of CloudWatch, go to all alarms. I don't currently have any. So I'm going to create one. First thing to do is to select the metric that you want to alarm on. And this is similar to choosing metrics for the dashboard like you just saw. So going to go back into the DocDB namespace, but this time I'm going to look for metrics by role. So I want to look for CPU utilization on any instances in the reader role in my cluster. So I select cluster metrics by role, put in the metric name, CPU utilization, and if I scroll down here, I will see the writer instance and reader instances CPU utilization metric for getting started with DocumentDB. In this case, I want the reader instances, so I will select that metric. So you see here the metric name, CPU utilization, the reader role. But I want to change the period to 1 minute because I want to know anytime within a 1 minute period where CPU utilization crosses my threshold of 14%, which is lower than what I talked about in best practices, but based on my cluster and data set and the load generation tools I've got, 14 works well to generate an alarm. So next thing I want to do is define what happens when the alarm goes into an alarm state. So I do want to send a notification. I'm going to use an SNS topic that I previously defined called demo topic. So it'll send an email to me when the alarm goes into alarm state. And the last thing that we need to do is provide an alarm name. So let me get an alarm name here and go to the preview. So here we can see everything that we just defined. We'll go ahead and create that alarm, and here we see it on the dashboard. Now I do have some tools generating some load on this cluster in the background, so probably within a minute or two this will go into an alarm state. But while that's happening, let's go ahead and go back to the presentation and talk about Profiler. So I'm going to use you're going to use the Profiler to find slow running queries in your DocumentDB cluster. You define a threshold, and any operation that takes longer than that to execute is going to be logged to CloudWatch logs. You can then use these logs to identify queries that are maybe not using an index, or if they are using an index, it could indicate that those indexes are not optimal. So best practice is enable the Profiler. All right, just have it enabled because it is disabled by default, and set an appropriate threshold. Now, enabling it is a two-step process. The first step is setting a cluster parameter group profiler, cluster parameter value that you see here. That needs to be enabled. Now, in order to modify cluster parameters, you do have to have a custom parameter group. So you may need to create one if you don't already have a custom parameter group. And since it is at the cluster level, this is going to apply to all instances and all databases in the cluster using this parameter group. So two associated parameters are the profiler sampling rate, and that's really the fraction of slow queries that you want logged, which is between 0 and 100%, or 0.0 and 1.0. 1.0 is the default, so every slow query is going to be logged. And what defines a slow query is based on profiler threshold ms, or profiler threshold milliseconds. This is the threshold used for logging. Any operation taking longer than the value, like you see on the screen here, 100, so is going to be logged to CloudWatch logs. So any operation taking longer than 100 milliseconds is going to get logged. Now, do keep in mind when you enable the profiler, it is going to consume additional resources. So we do recommend that you start with a high threshold value, maybe around 500 milliseconds, and gradually lower the value to identify slow operations. Right? Tendency may be to, let's just start it at 50 milliseconds. But if you start with a threshold, that value that is too low, it can cause some performance issues for high throughput applications. Again, because the profiler does need to use some of the resources on that instance. So you've set the parameter values in the parameter group, and now the second step is to enable the profiler at the cluster level. And the way you do that is you select the profiler logs option, like you see here, in the log exports section of the cluster settings. This can be set when you create a cluster, or you can change this by modifying an existing cluster. The profiler is going to log any of the operations that you see here that take longer than the threshold defined in the parameter group. And like I mentioned earlier, profiler logs written to CloudWatch logs. At each cluster that has profiler enabled, it will have a corresponding CloudWatch log group with a name as you see on the slide. And you'll see this in the demo. All right, that's going to be /AWS/DocDB/ your cluster identifier /profiler. Here's an example of a CloudWatch log record. And what you see here, there's quite a bit of information, right? If we just go through it, we see at the very top that this was a query. The TS, we see the timestamp when this query was executed. We see that it was executed against the world.people namespace or the people collection in the world database. And then you see the command itself. Right? You do see it was a find on the people collection. A filter was passed in, wanted to match on a first name of AFAE. Right? And then if we go down, we see that the execution time, millis, here, about 2/3 of the way down. It's about 1.9 seconds to execute it. And we see that this query performed a collection scan, or as it says here, a call scan, which is like a table scan in a relational database. Right? So it's something you don't want because it's going to read every document in the collection. You see the IP address that the request came from. You see the app name, which indicates Mongo shell. So we know somebody was executing this find command from Mongo shell, and it was user lab user. So very detailed outputs there. But one thing you'll notice that is not included is the results of that find command. All right, so that we don't log what results were returned. We just log that it was a find, there was a filter on first name equals AFAE. Now, because all profiler logs for the cluster are sent to a single CloudWatch logs group, you're probably going to want to filter that. So use log events filters to find what you're looking for. So in this slide, you see how to filter those events to show only slow queries on the cases collection in the cases database. You can filter on any value in the log entries. All right, for example, you could filter on all queries, you could filter on all inserts or requests from a specific client or user, etc. And in addition to filtering the log entries, you can use logs insights to visualize these entries. Right? So you can get like a histogram, showing you when these occurred and how many occurred at the time. So here you see the same filter, right? Cases collection and the cases database, but it shows when the top 10 slowest queries executed against that collection occurred. So you can filter the same way that you filter log events. You could say, look for all queries, all inserts, requests from a specific client, etc. And then lastly, just share some common CloudWatch filters that you can use. All right, so first one there, just show me the 10 slowest operations on a particular collection. Or show me all of the update operations that took more than 60 milliseconds. Now, granted, this is only going to work if your threshold is 60 milliseconds or less. Third one, show me the 10 slowest operations across all of the databases in the cluster. And then last one, just hey, show me all of the queries that performed a collection scan. So those are some examples of filters that might find helpful. All right, so with that, let's move into a demo of CloudWatch profiler logs. So to enable the profiler, remember you need to set the values in the parameter group. So what I'm going to do is, first of all, show you how to create a custom parameter group to set the value. So go to the parameter group section of your Amazon DocumentDB console, select create. We're going to give this parameter group a name. And we're going to base it off of the DocumentDB 4.0 parameter group. So go ahead and create, and I need a description. Okay. So now I have a new parameter group, but it still has the default values. So I need to enable profiling. So I'll go ahead and select that profile group that I just created. We see that profiler is disabled. So I want to edit it, change it to enabled, and go ahead and modify that parameter. And then my profiler threshold, again, for the purposes of the demo, I'm going to bring that down to the minimum of 50 milliseconds. Modify that. Okay, so now I've got my cluster parameter group set up to enable profiling. The next thing you need to do is go ahead and enable a profile log exports on a cluster. So I have a cluster here, this profiler and audit cluster that I want to enable profile log exports. So I'll go ahead and click on that and click on modify. And we see that I already have the profiler and audit parameter group applied that we just edited, because it does take a few moments or a few minutes to reboot after applying a custom parameter group to a cluster. So to save some time, I already have that custom parameter group applied. So we just need to go down and enable profiler logs export. So we check the box there, click on continue, and I do want to apply this immediately, and I'll click on modify cluster. Now if I click on this cluster, I see here that it is in sync, which is to be expected because I didn't change the parameter group, but we can see it is configuring log exports on these instances. So getting started with DocumentDB, it already has profiler log export enabled. So let's go take a look at these logs. So in CloudWatch, go to log groups. Again, the profiler logs, they all end in profiler, and I only have one on here for my getting started with DocumentDB cluster. So I go ahead and look at the log stream. So you see I've got a lot of slow queries. Again, because I set that threshold pretty low, and I've got some workload running on a collection that doesn't have an index defined. But let's just say I want to see how many, show me all of the slow queries that performed a collection scan. All right, and you see there's quite a few, all right, across multiple collections. The cases collection, the customer collection, there's aggregations, there's counts, there's distinct. All right, so a lot of different commands across a lot of different collections in my cluster here are running slow, right, or slower than 50 milliseconds. So that's how you can filter the log groups. Now logs insights, right, to get some visualization on this, I'll simply navigate to logs insights, and go select the log group that I want to get some insights on. And here, I just want to see the top 10 slowest operations on the customer collection in my PI database. So I'll go ahead and put that filter in, and need to increase my time range. All right, and you'll see that it matched 209 records, and it's showing 10 of them here that all occurred a little before and after 11 a.m. All right, and here I see those operations. There was a distinct operation and a number of aggregations. All right. And of course, you could create custom metrics on these, which I'm going to do a little bit later for auditing. But this gives you an idea of how you can enable profiling and then analyze those profiler logs. All right, so next, I'm gonna move into using performance insights to visualize load on a DocumentDB cluster. So allows you to visualize load. It allows you to determine which queries, hosts or applications are contributing to the load on your instance in your cluster. You can focus in on specific events or time ranges or look at trends across longer periods of time. And then lastly, there are some CloudWatch metrics that Performance Insights publishes that allow you to monitor and alarm on database load metrics. Now, before we dive into Performance Insights a bit, just maybe a bit of a cheat sheet, if you will, of differences between Profiler and Performance Insights, right? Kind of help you determine when to use which tool. Right, so Profiler that we just talked about, it's about identifying slow queries, right? Any operation that took longer than a certain number of milliseconds to execute. Performance Insights is all about finding queries, databases, hosts, applications, causing load on the cluster. So it's not necessarily about finding slow queries, but what's causing the most load. And we'll go into what load means. Profiler is at the cluster level. Performance Insights is at each instance level. Profiler, enable it, right, is a two-step process. It's via a custom parameter group and enabling Profiler log exports. Enabling Performance Insights, it's just a single checkbox in the UI. Profiler does, again, capture slow queries only. Performance Insights captures all operations, right? Whether it's queries executed by a client application or DML operations like creating indexes, right? Performance Insights is going to be able to capture all of those things. With Profiler, you're going to basically query the logs through CloudWatch. Performance Insights doesn't generate any logs that you can query or look at. It's all about visualizing it, and you'll see what, again, that looks like here shortly. Profiler is going to give query execution time information. Performance Insights doesn't give any query execution time information. Profiler is going to capture those execution plans for the slow queries. Performance Insights doesn't capture any execution plans for queries. So those are some of the key differences to keep in mind in helping you determine, should I use Profiler, should I use Performance Insights? All right. Now, at the core of Performance Insights is a single CloudWatch metric called DB load. And this metric characterizes how an application is spending time in the database, right, for a request. And it's measured in units called average active sessions. So what does all that mean? Okay, so an active connection or session that has submitted work to the database and is waiting for a response for it. All right, so that's an active session. All right, client has made a request, sent it to the database, waiting for a response. We consider that an active session. Now, if multiple clients are submitting requests to the database, there will be multiple active sessions at different times for each of these clients. Right here you see different active sessions for users 1, 2, 3, and 4 at different times. And now if we count the number of sessions that are active at a given moment, we see we've kind of sliced it up here, and we can provide a metric, right? And that's this DB load metric. So when that's averaged over time periods, we can see how busy an instance is during a particular period of time and how much time sessions are spending waiting for the instance to respond, right? So then when we stack those, like you see on the bottom here, you start to see we can get a nice graph of all of the active sessions on the database at these points in time and really understand which requests are causing load and what they might be waiting on. So enabling Performance Insights, as I mentioned, it's pretty straightforward. You can enable it at the cluster level when you first create a cluster. For existing clusters, you do need to enable or disable it at the instance level. A KMS key is required, and it is used by Performance Insights to encrypt any data and metrics in flight being sent to the Performance Insights backend, and also to encrypt it at rest as it's stored in the Performance Insights backend. Now, the main thing that you'll see in the Performance Insights dashboard, and you'll see it in the demo here in a few minutes, is the database load graph. All right, and what it shows is how the load compares to the instance capacity as represented by this dotted max vCPU line. All right, so this is a small T4G with 2 vCPUs. All right, so you can see that in this case, my database load is exceeding the number of vCPUs that I have. By default, this load is sliced or grouped by what we call wait states. So some wait states are CPU, like you see here, the green one. That means that this request or session is waiting on CPU. Another common one is I/O. It's waiting on I/O, right? Maybe to read something from or write something to the distributed storage volume. So in addition to slicing by wait states, you can slice by queries, applications, hosts, or databases. Slicing by hosts just simply groups the load by the host or IP address that made the request. Slicing by databases groups the load based on each database in the cluster. And I want to dive a little bit deeper into queries and applications on these following slides here. So simply put, if you slice by queries, that's going to group it by the query or the query digest. Now, if you just have a one-off query, you're going to see that query in the list of top queries like here. But if you have multiple queries, which is probably more common, all right, we have multiple queries with the same signature, meaning a query where you're looking up based on a name or based on a user ID, and you're projecting back the same values. Those queries are all going to be grouped into a single query digest. But then you can expand that to see the distinct queries. All right, it's a way so that we don't, basically fill up the list of top queries with 20 different customer lookup queries. We just create a single, effectively, customer lookup query digest. That way you can see other queries, more other queries in the display. And then top applications groups the load by the application that made the request. Now, a best practice here is to specify the application name in the connection string when you connect to DocumentDB. If you don't specify an application name, it's just going to use unknown. All right, so if all of them just get lumped into unknown, it's not going to really help you determine which application has created or caused this load. So definitely specify application names in the connection strings. The last thing I want to talk about is Performance Insights and CloudWatch. Performance Insights does publish 3 CloudWatch metrics. The first of those is DB load CPU. This is the number of average active sessions where it is waiting on CPU. Another way to think of this is these are the number of average active sessions where the query is being executed as consuming CPU resources. The second is DB load non-CPU. So this is the number of average active sessions waiting on some other resource, for example, I/O, meaning the query needs to read data from or write data to the distributed storage volume. And then lastly, DB load is simply the sum of DB load CPU and DB load non-CPU. Just like any other CloudWatch metric, you can set alarms on these. All right, so now let's jump into the Performance Insights demo. And to start, I'm going to go ahead and enable Performance Insights on an existing cluster. And now if you remember, to enable or disable Performance Insights on an existing cluster, it is at the instance level. So I'm going to go to my Profiler and Audit cluster and expand that. And I'm just going to enable it on one of these instances because it's the same no matter how many you're enabling, but you do have to do it instance by instance in the UI. So I'm going to select that instance, modify it, come down, select Enable Performance Insights. I do want to apply this immediately. Click Modify Instance, and that's it. That's all there is to enabling Performance Insights. Now I do have a cluster where Performance Insights is already enabled. I'm just getting started with DocumentDB cluster. So at this point I want to go into the Performance Insights dashboard. The first thing you need to do is choose an instance, right? Again, Performance Insights is at the instance level. And for my demo, I know my workload is going to this getting started with DocumentDB 3 cluster. So by default, the time period is an hour. And the first thing you see here are counter metrics. The CPU utilization is selected by default. You can clear that. You could choose other metrics. Things like active memory, network, receive, transmit metrics, things like that. But the focus for the demo here today is really on the database load. So let's go down here to database load. And you see that by default it is sliced by weight. And for the last hour, all of the average active sessions are waiting on CPU and a little bit of other. You can see by the color coding, green is CPU. But right now I want to slice this by database. All right, so this is just another way to slice up these metrics. So now instead of graphing it by how many sessions per, based on the wait state, I'm going to see how many average active sessions per database. And I also want to go out to a week here because I've got quite a bit of data. And you see that now I've got different databases. I've got about 7 different databases in this cluster that have load on them. And if I go down here, I can see for this time period, for all of these databases, here were the top weights. And the color coding is important. Like for this CPU weight state, this color here corresponds to my customer's database. The sort of pink color here corresponds to my YCSB database, and this blue corresponds to PI, and so forth. All right, so this allows you to see that for CPU, all right, it's been spread across multiple databases. I/O is primarily this YCSB database, and so on. The other way that you can look at this is the top queries. So again, for this time period of a week, here are the top queries. Again, that same color coding. So I see all of these queries were against the customer's database. And I mentioned a query digest earlier. We aggregate or group all of those together into this digest. Now here you can see the specific queries. So let me click on one of these. For example, here you see that the actual query running an aggregation on the customer's collection, matching on petdata.pet equals Martin, grouping by car data car maker, getting the count of those, sorting them from highest to lowest, and basically returning the top 3 highest from that aggregation. So you can see the specifics of each of the queries in the query digest. If I go over to top hosts, here I see the hosts that were executing these queries against these databases. So in this case, it's all the same host because I have a single instance that I'm using to run these various queries, but you can see that here. Database, this, if you slice it by the same metric that you choose down here, you're just going to see the same list. And then lastly, top applications. Now you see here, like I mentioned, you want to specify the application name and the connection string so it shows up. So here's some custom Python scripts that I've run, generating quite a bit of load, MongoDB shell, and then lastly, unknown. All right, so this, in this case, this was the YCSB test client used to generate some load. That doesn't pass in the application name. So as I mentioned earlier, all of that shows up in unknown. Now, let me go back to top databases, and I just want to focus on a particular database. So I can select it here, and if I scroll back up, you see that the load is now scoped to a particular database. And I want to go back in time to just the past 5 minutes, because I do currently have some load running against this database. Now I can slice by query. So now here I can see within a 5-minute period all of the queries executing against this database called PI. So if I scroll down, look at the queries, you can see I've got 3 different aggregations running on this collection in this database. Now when I created this database, I did define 2 indexes to support the second and third queries. I didn't define an index for the third query here. Now again, using this query digest, I can see what the exact query is. All right, I could basically take this query, get an explain on it in Mongo shell, and I would see that it's doing a collection scan. So what I'm going to do is go off into another browser window here, create an index on this car data.carmaker field that the query is using. And if I click refresh here, we should actually see, we see the create index operation currently underway. So nice thing about Performance Insights, it's a lot less of a wait. Within a few seconds, you'll see the metrics being reflected in Performance Insights. But that index build just finished, but we see it here as this dark blue. And we'll refresh it one more time. So we do see here, yes, that finished. And now if we let this go long enough, we'll see that this aggregation on car data.carmaker will be consuming a lot less, or will be having a lot less average active sessions. But in the interest of the demo, we don't have time to wait for all of that, but you can already see that the average active sessions graph has already got a lot less average active sessions for this workload. Okay, so that's Performance Insights. And now let's go back to audit logs. And auditing the different operations that occur in your cluster. Now, these operations can be what we call cluster operations, such as managing the users and the roles that have access to the database in the cluster. They could be DML operations that modify databases, collections, or indexes. And they can be data or CRUD operations on the data itself in the database. Now, similar to the profiler logs, audit logs are written to CloudWatch logs. So you can do all of the same types of things that we saw previously with profiler logs. You can do that on the audit logs. So enabling auditing. So best practice is to enable auditing, which is disabled by default, if you need to audit operations on the cluster. Because like the profiler, it is going to consume resources on the cluster, right? But if you do have auditing requirements, definitely want to enable it, right? Again, it's a two-step process. There's a cluster parameter group called audit logs that you need to set the desired auditing audit logs you want to capture. If you don't have a custom parameter group, you're going to have to create one. And again, it's enabled at the cluster level, so this is going to apply to all instances and all databases in the cluster. That cluster parameter group, there are a couple of values, right? It's not simply enabled, disabled. Those are deprecated, but currently still supported. But do recommend to use one or a combination of the following. So DDL, that's going to be database management operations, operations dealing with connections, user management, authorization. DML read, those are all read operations. DML write, those are all write operations. All is DDL, DML read, DML write, and none is none. So you've set the parameter to log the events that you're interested in. Last thing you're going to do is enable the export of the audit logs at the cluster level. So as I mentioned earlier, auditing is going to send logs for these types of events, these 6 types of events that drill into a little bit more in depth here. All right, so these are all the DML events. All right, now if you remember, there was DML read and DML write. So these DML events are the various CRUD operations performed on the data in the database. All right, so we have some that are read only, like count and find. And we have some that are write only, like delete or insert or update. And then we have some that are both, all right, things like aggregations, because aggregations can read data or write data. And these different find and modify, or find one and delete, replace, update, because they're a combination of a read, which is the find part, and an update, the modify, the delete, the replace, or the update. So those are the different DML events. The other 5 authorization events, the other 5 types of events. Authorization events are generated when there are authorization failures. So only authorization failures. And authorization is more about, is this user authorized to perform this action, right? Are they authorized? Do they have privileges to create a database, to drop a database? Do they have privileges to read data, right? So as you can imagine, if it's successful, we'd have an awful lot of audit entries for successful operations. So authorization events are only generated when there are authorization failures. Connection events, these are generated on successful or failed authentication attempts on a new connection to the database. So this is, think of this as connecting to the cluster. All right, were they able to connect or not? All right, maybe they provided invalid credentials. All right, so connection events generated on success or failure to authenticate. DDL events, these are generated on operations on collections, databases, indexes, and change streams. Role management events are generated when managing roles defined in the database. User management events are generated when managing users defined in the database. All right, so that's the 6 different types of events and the specific events that can be generated. So audit logs are written to CloudWatch logs, just like the profiler. Each cluster with audit logging enabled will have a corresponding CloudWatch log group. Name will be based on the cluster name, as you see on the slide here, but instead of /profiler, it'll be /audit on the end. Just a brief point about the events written to CloudWatch logs. DML events. All right, so these are all the CRUD operations. These will be logged in action type or A type auth check messages. So the auth, this is kind of double purpose. Right? So if you're auditing authenticate events, those will be auth check messages, and DML is going to be auth check messages. Right? So just something to be aware of there. All other events are going to be logged in action type messages corresponding to the action. Right? If it's rename collection, A type is going to be rename collection. If it's drop user, A type is going to be drop user, and so on. Right. So here you see an example of that DML operation. Again, the action type or A type is auth check. We see the timestamp of when the operation occurred. We see the IP address of the client that connected to the database to execute this operation. And we see who it was, right? It was lab user connected to demo database. And then here we see the command. All right, so the lab user executed a find command on the DML collection in the demo database. DML just happens to be a name of a collection I used for this demo. Right? There's no other significance there. Just want to make that clear. All right, but again, namespace is database.collection. And then you see this find, a filter on return any document where version equals 1, and just project the message attribute back in the response. So again, you can see the find command, but we don't log what was actually returned by the find command. And then lastly, result of 0 indicates that this was a successful request. A sample output for a DDL event, in this case, a create database. Right? So remember, DDL events are around databases, collections, indexes, change streams. So here, a database was created at this time, a request from this IP address. The user was lab user, and they created a database called audit. So that's examples of 2 different kinds of audit events. So similar, again, to profiler. You can filter these log events. So let's say, for example, you've got your audit logs and you want to look for authentication failures. Right, here's a way you could filter events to show those. You can filter on any value in these log entries. Right? For example, you could filter on user permission changes, database creation, or even updates to sensitive data, right? From that DML auditing. Right, it'll have what collection was the update executed against, what was the value that was passed in for the update, and who did it. So I don't cover it here in auditing, but again, you could use logs insights on the audit data as well to visualize audit events in the same way you'd use it to visualize slow queries, as covered earlier. But one thing I am going to cover here that I didn't cover in Profiler is custom metrics. Again, this applies to anything in CloudWatch, right? So it applies to auditing, it could apply to Profiler, all right? But I'm just talking about this in the context of auditing here today. So if you want to create a custom metric using this authentication failure example, you specify a few values, the pattern. Well, first of all, the name of the name for the custom filter, the metric filter, calling it auth failure, the filter pattern. Want to match any audit log event where the param.message attribute value is authentication failure. I want to store this metric in a custom namespace called DocDB auth metrics. And if you remember before from creating alarms and building dashboards, there was a DocDB namespace. All right, the different services will have their own namespace. Here we're creating a custom namespace for these custom metrics that we're defining. So DocDB auth metrics is custom namespace. The name of this new metric, we're going to call it, in this case, login failure count. And anytime there is an audit log entry that matches this filter, we're going to set the metric value to 1. So just a couple of parameters to create this custom metric. And once you do that, then you can use it just like any other metric. Right? So now we effectively have a metric that we can use to alarm on failed authentication attempts. And then just to wrap up the section on auditing, some CloudWatch filters that you might find useful for common scenarios for audit logs. So first one is a filter, just find all of the authentication failures, find all of the failed logins, find all of the unauthorized operation attempts, right? Maybe see, look, who's trying to create databases that doesn't have permissions to, right? Find all user permissions updates, right? Maybe you want to track and see who's being assigned new permissions. Or lastly, just see, hey, who created this database, right? We have a new database, who created it? All right, so if you have auditing turned on, you go filter on a type of create database, and you'll see exactly which user created these databases. All right, so now we'll switch over to a quick demo of auditing. All right, for audit logs, I'm going to go back to CloudWatch. I'm going to go to log groups, and I'm going to search for audit. Am I getting started with DocumentDB cluster? So here are all of the audit logs that have been generated on this cluster, and some things that that I can filter on here. If I want to just try and find all of the events dealing with, creating a collection. Sorry, need to type here. Find all of the collection creation events. This is going to go ahead and for all of my audit logs available in CloudWatch, get information on all collections that may have been created and who has created them. All right. Another thing I can do is, I'm going to search for this authentication failure example that we saw on the slides. All right, so you can start seeing the logs related to authentication failures. And if I want to create a custom metric based on this filter, I can just simply click on Create Custom Metric. I'm going to go ahead and give it a name. I'm going to create going to use an existing namespace that I already created, the StockDB auth metrics. Give my metric a name and a value. So every time we find a log entry that was dealing with authentication failure, the value is going to be 1. Go ahead and create that metric. And now if I go over into dashboards and say I want to add a new metric, all right, now I see this custom metric that I created on login failure count. All right, and right now, okay, so I did have a failed login about an hour or so ago. All right, but that's an example of creating a custom metric and how you can use it in CloudWatch. And I could set an alarm on this as well, the same way I set an alarm on CPU utilization. All right, so the last section here are around events and event subscriptions. So DocumentDB uses Amazon SNS to provide notifications when an event occurs, and DocumentDB groups these events into categories that you subscribe to so that you can be notified when an event occurs in that category. Categories like instances, clusters, cluster snapshots, parameter groups. Now these events are generated by default, so there's no additional configuration that you need to do to subscribe to these. You just need to set up subscriptions. So briefly, here's the different categories, right? I mentioned the clusters, instances, cluster snapshots, parameter groups, the specific events in each of these categories. For example, the maintenance event in clusters, right? That's going to get generated whenever some kind of maintenance occurs, such as patches being applied to the service, or parameter group configuration change. Right? Anytime someone has modified the value of a parameter in a parameter group, that's going to generate a configuration change event in the parameter groups category. So to subscribe, you specify a name of the subscription, how you want the notification sent, and typically it's going to be via SNS. And you're going to specify the resource that you want to subscribe to events in. You can only have one resource type per subscription. So if you want to subscribe to cluster events and instance events, you're going to need 2 different subscriptions. Then once you've specified the source type, in this case clusters, you specify which source the subscription will consume events from. All right, so in the case of clusters, is it all events or a specific cluster? All right, here I've selected a specific cluster. And then going even further, what cluster events do I want to subscribe to? Is it all cluster events or specific cluster events? So in this case, I just want failover, failure, notification events on the Getting Started with DocumentDB cluster. Now, if you do want to subscribe to different events on different clusters, again, that's going to have to be multiple subscriptions. And we'll wrap up with a quick demo on event subscriptions. So we'll go ahead and create an event subscription. Going to, for any event, going to send a notification to an existing SNS topic that I've got defined. And in this case, I want to subscribe to events on instances. And let's say I only want these 2 instances. Say these are my reader instances in my cluster. I only want to subscribe to events on my reader instances, and the events I want are, let's say, failure. I'm just interested in any kind of failure events that occur on the reader instances in my Getting Started with DocumentDB cluster. So now anytime a failure event occurs in one of those instances, I'll get notified via email. Okay, so in summary, so we've seen a lot today, all right? Seen how to use the monitoring and visibility capabilities of DocumentDB, right? Viewing available DocumentDB metrics in CloudWatch, using the profiler to find slow running queries, performance insights to visualize load on your cluster, auditing operations performed in your cluster, and subscribing to events that occur on the resources in your cluster. Now, a call to action, some next steps for you. We've got 2 QR codes. The first one here on the left is going to take you to the Amazon DocumentDB resources page. That's going to have links to documentation, scripts, tools, webinars, past reInvent sessions, and more. And the one on the right, the DocumentDB On-Demand Tech Talks. That page contains recordings of past DocumentDB Tech Talks and virtual workshops. So with that, I'd like to thank you for your time, and we'll talk to you all again soon.